This is lesson 2 from the chance topic, and this lesson is looking into unions and intersections. The learning goal for this one is to look into what a union and intersection is and how it relates to Venn diagrams, and the success criteria is to be able to determine the number and probability of a set of data using new terminology. Now, there is a lot to unpack with this topic, and more importantly, there's a lot of new terminology that you'll be looking into, which might seem quite foreign without context. So to look into this and to start this off, what I would usually do in a class setting is ask a question: how many brothers and how many sisters you guys have? Now, because it's a bit tricky doing this remotely, I'm going to just make these numbers up, and I'm going to put these numbers into what's called a two-way timetable. So this right here is a two-way timetable. And this two-way timetable has a lot of significance in regards to how to represent numbers of something and the probability of something. And it's broken down into mainly two parts: brother and sister. But you can also see there's also this category of having no brother and no sister, or not sister or not brother, depending on your terminology. I put no and not for both of them because both of them are used interchangeably. So say for instance there is a class of 20 students. Right? So total all up is 20. And I ask each student individually, how many brothers and or sisters do you have? Regardless of whether it's full brother, half brother, or step brother or sister, I just asked the question. And these were the different responses that I got all up. So we have 4 here, and I'll explain what each category means. We have 4 here, we have 10 here, we have 1 here, and we have 5 here. So in the intersection, no pun intended, where we have a brother and a sister, in this scenario there are 4 people within this class of 20 that have both a brother and a sister. It doesn't matter how many brothers and sisters they have, we know that they have a brother and a sister. In this category here, we can see that they have no brothers and they have no sisters. So that's 5 people. They're only child, in other words. So there's 5 people within the class of 20 that are only children. Then there are these 2 different categories here where we have 10 people that have sisters. They don't have any brothers, so they just have a sister or sisters. So there's 10 people that have sisters but no brothers. And then conversely, there's only 1 person that has a brother or brothers but no sisters. When you add all of these up, you should get the total of 20, because this will be based on how many people we started off with, which is 10 plus 5 is 15, plus 4, 19, plus 1, 20. And this here, really simple to interpret. We now need to dig into the totals of each subcategory. So let's look at the amount of people that have brothers. Regardless of whether they have a sister or not, the amount of people in the class that have brothers, maybe 1 or more than 1, are 5. It's a total of 4 and 1. And then the amount of people that have no brothers, regardless of whether they have a sister or not, so this is the single or the only children, and the people that just have sisters, it's the addition of that, which is 10 plus 5, which is 15. These two, when added up, should equal 20, which it does. 5 plus 15 is 20. And then we do this again. Sisters, regardless of whether you have a brother or no brother, you add this up, it will give us 14. And then 1 plus 5, which is 6, regardless of whether you have a brother or no brother, the amount of people that don't have sisters is 6. 14 plus 6 gives me 20, so those totals check out as well. Now remember, these are just arbitrary numbers, random numbers that I got with just a random number total amount of 20. This could always change, but regardless of what number this is, all the 4 internal numbers should add up to 20, and each row across or column down, when added up, it should also equal 20 as well. So let's use this example to help us out, namely with the terminology. Now you'll notice that there was key specific words that I said, whether you had a a brother and a sister, or whether you had a brother but no sisters. The terminology, it can be used with symbols. So we'll look down here, and this is just the same thing from the top. But instead of writing brothers, I've just left it as B. And instead of writing no brothers, there's this thing called a B dash. So that little apostrophe here, this is called or pronounced as dash. So that just means not be, or not having a brother. Same with sister, there's sister and or S and S dash, so not having a sister. So the dash just means not whatever the category is, right? So the opposite of this. So let's come up with these different terminologies, and we can use these symbols here. Right here, where it has sister and brother, we're looking at, we'll go brother and sister. So if you have a brother and you have a sister, we use this terminology that looks like the letter A without the line. And this just means and. So this category, and how many do we have? I think I wrote 4. Yeah. So the amount of people that have a brother and a sister, in this case, is 4. And we use this and actually quite a bit. The amount of people that have a sister and no brother, so B dash, this is a terminology that we use. So this and is just used universally. So and that amount there was 10, so I'll put a 10 there. So this terminology looks a bit abstract or quite random or new to you. You probably have never seen this before. Possibly in year 9 you have seen it, but it is new terminology. But it really makes no difference, because all of this just means is brother and sister, or sister and not a brother. So the other ones, we can either have a brother and no sister, so S dash, or we can have no brother and no sister, so B dash and S dash. Again, it's just easy terminology to make life easier for mathematicians. So that was 1 and 5 respectively. So this is 1, just change color here, 1 and 5. Okay, so other terminology that we can use is the total amounts. So these total amounts might seem like we're going to use crazy terminology. It's actually quite simple. This one here, we're determining how many brothers you have, regardless of whether you have a sister or not. So people will write, oh, this would be B and S dash, but actually it's just how many brothers you have. So it's just B, really. Meaning this one here is how many brothers people don't have. It's just B dash, regardless of whether they have a sister or not. It's just B dash. So you can imagine this is here, S and S dash. And that's it. That's all there is for the terminology. The total doesn't have its own term, and you can call it the universal set, which some mathematicians or statisticians will use. But for now, we'll keep it just blank. So this is 5 and 15. This was 14 and 6, with a total of 20. Now you'll see that here this just means dash, which just meant not. This one here, this is a U, and this means union. All right, and union, all union means is everything that's included. So whether you have a brother or a sister, or you have both, so that would just be this one, and this one. We're not including the B dash and S dash, and we'll look in this when we look at a Venn diagram, which I'll explain in a second. So you will also see this terminology here where it has a little N in front of it, and then it asks for a specific thing. The N, this N, it just stands for the number of. I'll put it up here. Number of. So if you were to read this as a sentence, this is just saying, what's the number of people that have a brother and a sister? Well, we already know this. This is 4. What's the number of people that have a brother and not a sister? So brother and not a sister, well, this is just 1. And all you're doing is just extracting the amount. This is number of people that have a sister and no brother, so that's 10. Number of people that don't have a brother or sister, that's 5. Now, the union, BUS or SUB. This means that I want to know, let's say someone, a teacher came into this classroom and they said, okay, I need to know how many people have siblings, regardless of whether you have a brother or a sister or both. I want to know how many there are. So this will be the people that have both a brother or sister, which is 4, the people that just have a brother, which is 1, and the people that just have a sister, which is 10. 10 plus 4 plus 1, which is equal to 15. So it's almost like we're excluding the people that don't have a sibling. Another way you can think of this is just 20 take away that 5, which again also gives us a 15. So while this does look intimidating, it's actually quite simple. Now remember, these letters are just used for brothers and sisters. Sometimes they'll use different letters depending on the context of the question and what letters they decide to use. If we move across, you'll notice that the questions are also asked again, but this time they have a PR in front. And remember, PR just means the probability of that event happening. And it's a kind of weird probability of a certain event happening. This is not necessarily an event. This is me asking questions. But what it's actually saying is, let's just picture that same teacher comes into the classroom again and says, what's the likelihood of, if I choose someone at random, what's the fraction that I will choose someone that has both a brother and a sister? Now we all know that all of these probabilities will be out of 20 because it's always going to be out of the total amount. In this case, the amount of people that have a brother and a sister is a 4 in 20 chance, which is 4 to us. That's a 20% chance. You can simplify that down to 1 over 5. So there's a 1 in 5 chance that teacher comes in and picks someone at random, or 20% chance that they will both have a brother and a sister. Obviously, this probability will decrease, the percentage will decrease as the amount of people that you're choosing increases, assuming that this stays the same. The probability, again, this will be out of 20. Probability of having a brother and not a sister. So probability of having a brother and not a sister, which is 1. So this is a 1 in 20 chance, or 5%. And all you got to do is just find out what the number is relative to and put it out of 20. And if it can't be simplified, you will simplify it. I'll just write here 1 over 5. Probability of sister and not a brother is a 10 out of 20 chance. So this is half chance, or 50-50%. If I choose someone that has a sister and not a brother, which is a high percentage if you consider the number within there. It's the highest number within the category. Probability of not brother and not sister is 5, so that's 5 out of 20, which can be simplified to 1 over 4, or a 25% chance. And the probability of having a brother union sister, so whether we have a brother or a sister, both, or just one, it doesn't matter. It's 10 plus a 4 plus a 1, which is a 15 out of 20 chance, or 3/4, 75% chance. So the terminology, while it does seem, again, intimidating and confusing, it's actually quite simple once you know the context. Now the last thing we're going to look into before I wrap this one up and finalize it is this here, which is called a Venn diagram. So a Venn diagram created by the mathematician Venn. I think Venn is his last name. I'll pop a picture of him up right now, assuming that I remember to do this while in the editing suite. This is him right here. He created a really nice diagram to represent this information visually and not through two-way timetables. So in other words, let's put this circle here as category B for brothers, and this category here as for sisters. So the best way to start this one off is looking at the intersection, that overlap. So this is 4. This means that 4 people out of the 20 have both a brother and a sister. So 4 belongs into this category. And then the amount of people that have a brother and not a sister is 1. So we're going to have 1 here. So it's just one person that just has have brothers, or just one brother, it doesn't matter. We know that this is one person. If we look at this full circle, the amount of people that have brothers, regardless of whether you have a sister or not, is 5, and we know this because it's 1 plus a 4. The amount of people that have sisters and just sisters with no brothers is the 10. So we're going to put 10 in here. So the people that have sisters, regardless if they have a brother or not, is the 10 plus 4, which is 14, which is what we have here. And then we also got to consider the people that don't have siblings. Those 5 people that are just only children, they go on the outside. They don't belong to any of these categories, so they belong to the outside. So if we were to add up all these numbers, we should technically get 20, which we do. 1, 4, 10, 5, all added together will give us 20. So this is a Venn diagram. Really, really simple, a nice visual way of representing this information. And again, all of these terminologies that you get from here can also be represented within here. But the main one I want to indicate is this one here, and this one here, and this one here. This is B union S, if you were to look into all of them. Okay, so this is BUS, or it looks like it says bus or sub. This is coincidental based on the letters that I've used, but this is the union, all of them together. Okay, if I were to just talk about this section in here, and we don't want to consider A, this is B and not S, because we're not including how many sisters there are, it's just the brothers. This one, I'll change the color to maybe a green. If we're looking into this one over here, this one here is S and B dash, so not brother. This little one in the middle is the intersection, so right in here. So this one I'll put up the top. This is B and S, so we just want to know what is in the middle of those two. But all of them together is B union S. Now some people get these two confused, B and S and B US, because they think, oh, and that must mean all of them. No, it's specifically talking about if you have a brother and a sister. So I want to know that specific amount, which in this case is 4. But the union, we're all united together, not the 5, but all union together. That's what the union stands for, so that's B union S. So there's other key terminologies, symbols that you need to know of as well, which I'll put to the side over here. The first one is called a null or empty space, and that just means that it's dictated, first of all, by something that looks like this. These are squiggly brackets with nothing in the middle, or a circle with a line through it. And this just means that, say for instance, we were to do the survey, and one of these categories we had 0 as our answer. So there was 0 people that had maybe a sister and no brother. There was nobody that belonged to that category. You would just say that that was a null or empty set just for that specific category, or that specific portion within two-way timetable. So that's null or empty set. The other terminology that we can also look into is when we're talking about the total amount. Now I did say that it's not generally used, but it does look like this weird symbol that looks like this. And this, I always think of it as a letter E, E standing for everything. And the everything just means the total amount. In this case, it was 20. So this symbol is just equal to 20, because 20 people were surveyed for this specific question. There's another one, and this one talks about whether something is considered mutually exclusive. It does sound very fancy, but all this means is that if A and B, in this case it would be B and S, or S and B, is equal to a null set. In other words, if I were to ask this question and there were people that just had a brother and no sisters, and just had a sister and no brothers, and there was no intersection between the two, or this right here was equal to 0, then we say that that is mutually exclusive, because there's no intersection. So technically we could have drawn this Venn diagram as two separate entities like that, where this would have been B and this would have been S, and you put your number in here, you put your number in here, you put your outside number, but there's no intersection. There's no intersection of some sort. Okay, in this case there is, and there's 4. But if there was people that didn't have a brother and a sister, you would say that the categories are mutually exclusive, and to be mutual just means that you've separated. On good terms, obviously, exclusive, so you separate it. This is it, 22-minute video. I'll wrap it up with that one, and you can go ahead, check your log sheet, see which questions you need to do. Remember, you can always check the different examples from the textbook as well to see if you need a bit of more clarity on something. But for now, we'll wrap it up at that, and I'll see you in the next video. Bye-bye.